All right, our final video for chapter 5. We're going to wrap up all of our quadrilateral stuff today. So yesterday we learned about how we were going to prove that this four-sided figure was a parallelogram. Today we're going to learn how to prove all the other types. So yesterday we focused mainly on parallelograms. Today we're going to do all the other types. Now parallelogram is the most important because remembering our quadrilateral family tree, so many of our quadrilaterals are actually parallelograms, right? They're just more specific and more special because they're farther down on that family tree. So we are going to use things that we talked about yesterday today as well. But today we're going to focus on all the other types. So here we go. So again, you're going to want to make sure that you have a nice, good list going after this. So we're going to do one at a time. The first one we're going to talk about is how do I prove that a four-sided figure is a rectangle? So we're going to focus on rectangles first. Now remember, a rectangle is in the parallelogram family tree, right? So if I know that I have a parallelogram already, how would I know then that this parallelogram is more specific to be a rectangle? But also then, what if I don't even know it's a parallelogram? How would I just take it if it has four sides? What are the specific properties that would make it a rectangle and nothing else? So yesterday we talked about with that parallelogram, right? I'm looking at my properties list and I'm saying, okay, what in this list would prove that I have a rectangle and not something that's not a rectangle, right? That would prove it's a rectangle and not a rhombus, that it's a rectangle and not a kite or a trapezoid or something like that, right? We also want to do it in the most efficient way possible. So since it's in the rectangles in the parallelogram family tree, there's two methods that we could use to prove if I already know that it's a parallelogram. So we're starting with the fact that I have a parallelogram. So either be given or prove that you have a parallelogram first. And then once I know it's a parallelogram, how would I know if I have a rectangle? So if I have a parallelogram already, and this parallelogram contains at least one right angle. Now, why is only one? Why is that all that we need? Well, let's think about it, right? If I know that I have a parallelogram, then I know that the opposite angles are congruent, and I know that consecutive angles are supplementary, right? Those are the properties of a parallelogram. Well, if one of these angles is a right angle, well, then the one across from it is also a right angle. And if I know the consecutive angles are supplementary, well, right angle and right angle, if they have to add up to 180, that means that all of them will be right angles with just knowing one of them if I already know it's a parallelogram. So if I have a parallelogram and one right angle, then I must have a rectangle. The second one would be is if I know that I have a parallelogram already, if I know that I have a parallelogram and the diagonals are congruent, then it must be a rectangle because the diagonals are not congruent in a regular old parallelogram and the diagonals are not congruent in a rhombus. So it would have to be a rectangle, right? Now, diagonals are congruent in an isosceles trapezoid, but if I already know it's a parallelogram, then there's no way it's an isosceles trapezoid because they're not in the same family tree, right? I've already ruled out that it's an isosceles trapezoid. You could also think if it's a parallelogram, then I know that both pairs of sides are parallel, so it definitely cannot be an isosceles trapezoid. So if you know you have a parallelogram and you have one right angle, or a parallelogram and the diagonals are congruent, then it's got to be a rectangle. Now, if I don't know that I have a parallelogram at all, what if I just know that I have a four-sided figure here? So any old quadrilateral. What is the defining factor of a rectangle? Well, that is that all four angles are right angles, right? So if I have any quadrilateral at all, if I can prove that I have four right angles, the only shape it could be is a rectangle. Now, you're probably going to say, but Ms. Crivo, it could be a square. True, but a square is a rectangle, right? So it's underneath in that family tree, so it's fine, right? It is a rectangle. It just is a more specific kind of rectangle. So that's okay. But there aren't any kites, there aren't any trapezoids. Those don't have right angles. So as soon as I have all four right angles, gotta be a rectangle. So those are the 3 ways of proving that I have a rectangle. Same idea here now with a rhombus. So again, the rhombus is in the parallelogram family tree. So one way is to prove or be given that you have a parallelogram first. Or what about if I don't even know it's a parallelogram, right? So first one's here, be given or prove that we have a parallelogram first. If that's the case, if I have a parallelogram, if this parallelogram contains one pair of consecutive sides congruent. So I know that a rhombus has all sides congruent, but if I know that I have a parallelogram already, remember that my opposite sides are congruent in a parallelogram. So if I know that it's a parallelogram already, and I just have one pair of consecutive sides congruent, well, that means then that the side across from that, oh, that's congruent, and this is congruent. So if all I have is one pair of consecutive sides congruent, as long as it's a parallelogram, then all of them would be congruent as well. All right, the next one says, if I have a parallelogram, so I already know that I have a parallelogram. If I have a parallelogram and one of the diagonals bisects the opposite angles. So if I have a parallelogram, then those angles are congruent, right? But if I have a parallelogram and one diagonal bisects the opposite angles, then it has to be a rhombus. The only other shape that has a diagonal that bisects a pair of opposite angles is a kite, right? Now a rhombus does have to have both. However, if I already know it's a parallelogram, then I know that it can't be a kite, right? Because I know that both pairs of opposite sides are congruent, which rules out kite already. And then the only type of parallelogram that has the diagonals bisecting the opposite angles, that's got to be a rhombus. So all you need is one, because once you know it's a parallelogram, the only kinds of parallelograms that have diagonals bisecting angles is a rhombus. All right, the last one then, if the diagonals of a parallelogram are perpendicular. So again, if I know that I have a parallelogram, already, then I know that the diagonals are bisected, but if my diagonals are perpendicular and they're bisected, then it has to be a rhombus. All right, so the only other shapes that have perpendicular diagonals are kites, but again, once I know that I have a parallelogram to start with, that rules kite out. So the only type of parallelograms that have perpendicular diagonals is a rhombus. So 3 ways this time to prove that a parallelogram is a rhombus. So what if I don't know it's a parallelogram? What if I just have that it's a plain old quadrilateral, just 4 sides, right? What is it that's going to make it a rhombus? Well, the most defining factor is that these 4 sides are all congruent. That's what makes something a rhombus. So if I can prove that, as long as if it has 4 sides and all sides are congruent, there's nothing else it could be. There are no other equilateral quadrilaterals out there, right? So it's got to be a rhombus. The other thing is if you have your 4-sided figure, right, and if you prove that both diagonals are perpendicular bisectors of each other, not just one, but both, right? If all I had was one diagonal as the perpendicular bisector of the other, that could be a kite. But if I prove that both of them are perpendicular bisectors, then it would have to be a rhombus. So there aren't any other shapes that have perpendicular. So when it's both, that rules out kite, and it has to be a rhombus. So I have 2 methods to prove that a quadrilateral is a rhombus without using that it's a parallelogram to start with. So lots of ways to prove a rhombus, right? 3 ways if you know it's a parallelogram, 2 more ways if you don't even know it's a parallelogram, you're just starting from scratch. Okay, the next one is a square. You can see the kite is down here too, because the square, I mean, you know, it's just a rectangle and a rhombus. Now it looks like a very short list, but it's in fact a very long list. So really the idea here with a square is you need to pick one method, of proving a rectangle Oops, I should have highlighted this other word, right? This should be highlighted, but you get the idea. So pick one method of proving a rectangle, and then pick one method of proving a square, or of proving a rhombus, sorry, proving a rhombus. And if you can do both of those things, then it has to be a square. So if you were going to write out a huge proof proving something as a square, right? Whatever method you're going to have, whether it's you prove it's a parallelogram first and pick one of those, or you start from scratch and you pick one of those, as soon as you say, okay, then this quadrilateral ABCD is a rectangle, using your reason, then you look at your list for a rhombus and you pick one of those methods, whether it starts as a parallelogram or doesn't, right? And you have a step that says ABCD is a rhombus with that reason. And then once you have both of those steps in your proof, you can have a final step that says ABCD is a square. If a quadrilateral is both a rectangle and a rhombus, then it's a square. So that's the idea, right? So there's a lot of options. You'd have to pick one from this list for rectangle, and then you'd have to pick one from this list for rhombus, and then once you get both of those, then you add another step that says then it must be a square. All right, kites. So kites are really funky shapes, right? They're a little bit different. A kite is not in the parallelogram family tree, so I don't ever start with that as a parallelogram, because once you know it's a parallelogram, it can't be a kite, right? So this one has to start by just a plain old four-sided shape. So if you have a four-sided shape and it has those two disjoint pairs of consecutive sides congruent, then it has to be a kite. So you could start here and prove our two pairs of congruent sides, right? That would prove that it's a kite. You could also prove that if you have the diagonals are perpendicular, then it has to be a kite. So if I just have perpendicular diagonals just like this. Now, you're probably saying, but Ms. Crivo, you said that a rhombus has perpendicular diagonals. You're right, but remember the family tree. A rhombus is connected to a kite. So it could have both diagonals, perpendicular bisectors. That's fine. All we need is one. As soon as it has one, it's a kite. If it has both, then it's a special kite called a rhombus. So if you just prove that those diagonals are perpendicular, it's got to be in that kite family tree, right? Which connects to rhombus, and it connects to square. But that's all I need is that it's perpendicular, and I'll know it's a kite. The last one here, if one of the diagonals of a quadrilateral bisects the other. So if one diagonal is bisecting, then it's a kite. Now this one is tricky, again, right? Whoops. Actually, I think this one there's a typo in this one. I apologize. If one of the diagonals of a quadrilateral bisects the opposite angles, then it is a kite. So I apologize if I've already written that, sorry. Erase, rewrite. If one of the diagonals of a quadrilateral bisects the opposite angles, then it is a kite, right? If we had bisecting, it could be a parallelogram, and a parallelogram can't be a kite. But instead, if I have it bisecting the opposite angles. So all I need to know is that one of these diagonals is bisecting the opposite angles. Now you could say, but Ms. Crivo, what if the other one does too? That's okay. If both of them do, it's a rhombus. But a rhombus is a kite, so we're okay. So all I need to know is one of them does. If one diagonal bisects the opposite angles, then it's got to be a kite for sure. All right, so we've got all of those shapes now. That all that's left, oh, I apologize, there you saw my family. The only thing that we have left is the trapezoids. Now, all we have here is like methods of proving an isosceles trapezoid, but that's because really the only way to prove that you have a trapezoid is to prove that you have only one pair of opposite sides parallel. So the other pair has to be not parallel. So the tricky part about that is that really you're probably going to be given that it's a trapezoid, right? Most likely you'll say, this is a trapezoid, now prove that it's an isosceles trapezoid. So because it's so difficult, and there is actually a method for proving something is not parallel, but we didn't really go through it this year, so we're not going to ask you to do that. So you'll most likely be given that you have a trapezoid, and now you just need to prove that that trapezoid is isosceles. So again, these are all methods. So as soon as you know that you have a trapezoid, to prove the trapezoid is isosceles, then we could say, okay, the non-parallel sides, which we know are called the legs, right? The non-parallel sides of the trapezoid are congruent. If you know that, then it has to be an isosceles trapezoid. Remember, you have already ruled out parallelograms because you know it's a trapezoid already. So as soon as you know that those non-parallel sides are congruent, it's isosceles. Next one is if you have this trapezoid and you know that those upper base angles are congruent, then it's got to be isosceles. Same thing as if you have your trapezoid and you know that the lower base angles are congruent, then it's got to be isosceles. And then the last one, as long as you know that it's a trapezoid and then the diagonals are congruent, then it's got to be an isosceles trapezoid because that's only true of isosceles trapezoid. Okay, and again, remember that we already know this bottom one for sure, right? All those other ones are kind of specific to only isosceles trapezoids. But down here at the bottom, the diagonals are also congruent in a rectangle, yes, but you already know it's a trapezoid. And once you know it's a trapezoid, then you know for sure that it cannot be a rectangle. All right, that's our whole list. Woo! Hopefully you paused and got caught up with whatever you need. So now we just got to see how are we going to use it. Now, yes, we can write full proofs, and I'll show you a proof. But, you know, sometimes we're not going to be given a proof. We still have to use that idea of what do I know and what can I prove, right? So back to these ones. We practiced these a little bit yesterday, actually 2 days ago, when we just knew the properties. But now we can be really specific. How do I prove that I have one of these shapes? So if you look at this one in the top left here, all right, well, I'm noticing that the diagonals are bisecting each other, right? Diagonals, both diagonals, I should say, both diagonals bisected. All right, if the both diagonals are bisected, that was a way to prove that I have a parallelogram. Notice, though, that they are marked differently. So I notice that the diagonals are not congruent. So what does that rule out? Well, that rules out a rectangle, right? I can't have a rectangle if my diagonals are not congruent. So that kind of ruled that out. What I do see, though, the next thing I see is that these two consecutive sides, so one pair of consecutive sides are congruent, so I already know I have a parallelogram, and one pair of consecutive sides are congruent. Well, that was a way to prove a rhombus, right? Parallelogram, one pair of consecutive sides congruent, there it is. So it's got to be a rhombus. All right, let's go to the top right over here. So in the top right, I'm noticing, so you might be a little bit confused, these two dots, and like sometimes we just run out of ways to mark things, but this really means, that these two are congruent as well. So I notice, I notice that I have one pair of opposite angles congruent, right? That's these guys. I should probably have marked this in a different color. There we go. And I'm noticing that the diagonal, one diagonal, bisects opposite angles. Well, both of those, right? Even without that, both of those would probably have been enough. But with both of them, which is the only shape where I have one pair of opposite angles congruent, one diagonal bisecting? What's the one that has all the one? That would be a kite. And we could go back and look at our list, right? So proving something is a kite, I have one of the diagonals bisects the opposite angles. I have one pair of opposite angles congruent. That would be a kite. All right. Now if I look in the bottom left, notice I see here that it says segment AC is congruent to segment BD. So that is, AC is this diagonal, right? And BD is this diagonal. it is kind of hard to mark diagonals congruent, so we could do something like this. Okay, so I know that I have my diagonals are congruent. And if that was the first thing you notice, be careful, right? Now, diagonals congruent could either be a rectangle or it could be a trapezoid, so we got to look and see what else we have. Let's see, I have one pair of opposite sides are both parallel and congruent. One pair of opposite sides, both parallel and congruent. Wait a second, that was a method we learned yesterday. One pair of opposite sides, both parallel and congruent, that proves that I have a parallelogram. So if I have a parallelogram and the diagonals are congruent, parallelogram and the diagonals congruent, that was a rectangle. So once I knew that I had a parallelogram, then isosceles trapezoid is ruled out. Sorry, too far. So this one must be a rectangle. All right, now, last one. This is interesting. This one looks awful lot like the first one that we did. Well, let's take a look here now. Again, I'm noticing, right, both diagonals are bisected. So that tells me that I have a parallelogram, right? That was one of the methods yesterday. Oh, but now I'm noticing, look at how they're marked. They're all marked exactly the same. So that means that the diagonals are congruent. Oh, so they're bisected, but they're also congruent. So diagonals, bisected is parallelogram. If I know it's a parallelogram and the diagonals are congruent, well, that's what I just did over there on the left. That was a rectangle. But wait, there's more. Now I also see that I have a pair of consecutive sides here that are congruent. Well, consecutive sides congruent in a parallelogram, that told me a rhombus. That was like the first one, right? Hang on, if I have a rectangle and a rhombus, if I can prove it's a rectangle and a rhombus, then this must be a square. So that's kind of how you go through that, right? Okay, this property would prove that it's this one would prove it's that, right? And keep on going until you get as specific as you possibly can. So that's how to use those ways to prove things without actually writing a formal proof. But, you know, we probably do need to write a formal proof. This one won't be long, though. I wonder if you could do it on your own. Pause your video, set it up, and see if you can do it. First step says that ABCD is a parallelogram, given. So I know my big shape is a parallelogram. I know that for sure. All right. Step 2, segment BD bisects angle ADC, and BD bisects angle ABC. Now you could put that all together just like they have it in the given, but this kind of helps me wrap my brain around it a little bit better. So segment BD bisects angle ADC. So these two angles are congruent. And segment BD bisects angle ABC. So these two are congruent. So I was a little risky there, and I marked them congruent even though I didn't put congruent angles in my picture, or in my proof, but we got the idea, right? And I'm trying to prove that ABCD is a rhombus. So I know that it's a parallelogram, and I'm trying to prove that it's a rhombus. All right, let me look at my list. Here's my rhombus list. I'm looking at the top section here, right? Because I already know it's a parallelogram. Consecutive sides congruent. Okay, don't know anything about the sides yet. If one of the diagonals of a parallelogram bisects the opposite angles, there it is, straight up, right? I have a diagonal and it's bisecting the opposite angles. This has to be a rhombus. Boom, I'm done. 3-step proof. the big idea is I wanted to make sure you knew how to write this. So step 3, using that really good if-then form, A, B, C, D is a rhombus. Now remember, there is no symbol for rhombus or rectangle or trapezoid or anything. The only symbol is parallelogram, since that's the one we use the most. So then I want to put in good if-then form, if a diagonal of a parallelogram bisects the opposite angles, then it is a rhombus. So you can use all those things, right? Just like we did in the if-then form, we wrote it down in perfect form just so that you can just grab it and plop it into your proof the way it is. All right, last one is kind of a bonus one. This one will probably show up as, you know, maybe a purple problem or something like that. But, you know, in chapter 4, at the end of chapter 4, we did all this stuff with slope and coordinates. And so we wanted to kind of link that and show you, hey, you can still use that idea even when we're talking about parallel lines and perpendicular and parallelograms and all these different things, right? So we are going to try to give the most descriptive name for this quadrilateral. Now, most descriptive means that, okay, if I can say that it's a parallelogram, awesome. But if I can say that it's a rectangle, that's more descriptive than parallelogram. And if I can say that it's a square, that's more descriptive than a rectangle. Maybe I can't say all those things, but you want to go as far as you possibly can. So how am I going to use coordinates and this idea of slope that we did from chapter 4 in order to prove all these things? Well, I'm definitely probably thinking if I wanted to try to find out if it's a parallelogram or not is probably my first step, right? Since that's kind of the building blocks for a lot of these. So to figure out if things are parallel using slope, I would need to see if they have the same slope, right? So this is review from chapter 4. So if I wanted to find the slope of, let's say this segment here, BC. So if I'm finding the slope of BC, then I would be, let's see, subtract the y's, 9 minus 1, over subtract the x's, 3 minus negative 9. So this would be 8 over 12, which would give me 2/3. All right, working my way around here. Let's see, say I do this one. CD, same idea, right? Finding the slope here. Subtract the y's, 9 minus 1, 1. Subtract the x's, 3 minus 9. This gives me 8 over negative 6, which is negative 4/3. All right, down here at the bottom, segment CD, slope of this, I would do 1 minus negative 7 over 9 minus negative 3. Two negatives turn to a positive, so I get 8 over 12, which gives me 2/3. Interesting. And my final side, whoops, over here, BC, I would have 1 minus negative 7 over negative 9 minus negative 3. 8 over negative 6, which gives me, didn't leave enough space, negative 4/3. Ooh, okay. Take a look. Opposite sides have the same slope, right? So if I have both pairs of opposite sides that have the same slope, that has to be a parallelogram. Okay. Both pairs of opposite sides are parallel, right? Same slope. That tells me that I have a parallelogram. I'll write it out. Now, I can't stop here though, right? I know that it's a parallelogram, but what if it was a rectangle? Or what if it was a rhombus? How am I going to figure that out, right? Well, let's think. Rectangle and rhombus. Okay, well, rectangle I know that I would have to have right angles, right? So if I had a right angle here, that means that my slopes, let's see, that means that these would be perpendicular, right? If I had a right angle there, then those two lines are supposed to be perpendicular, and the slopes are supposed to be opposite reciprocals. Oh, but they are not, right? If I look at my two slopes that are right next to each other, they are not opposite reciprocals, which means that they're not right angles. So that tells me then that a rectangle is out, right? Not a rectangle. So it turns out that it can't be a rectangle, which means it can't be a square either, but I have to check. I have to see if it is or not. So this is definitely not a right angle. Okay. Well, how am I going to figure out a rhombus then? What was special about a rhombus? Oh, the diagonals. The diagonals were perpendicular in a rhombus. So if I draw in my diagonals and I find the slopes of those diagonals. So here we go, slope of this one. Oh, 1 minus 1 over 9 minus negative 9. That'd be 0 over 18. Oh, that's the slope of 0, huh? Okay. Well, what's the slope of my other one? Well, it's definitely not looking like it's going to be perpendicular, right? But we'll double check just in case. I'm running out of room. Maybe I can squeeze it in here. Let's see. 9 minus negative 7 over 3 minus negative 3. That gives me 16 over 6, which is 8 over 3. That is not perpendicular, right? So my two diagonals are not perpendicular. So that's not a rhombus. All right, so I ruled out rhombus, I ruled out rectangle, which means the most descriptive name that I could give is a parallelogram, but you have to check, right? You have to keep going and check the others, because if one of those things should happen to be true, then a rectangle would be more specific or more descriptive than parallelogram. But that's the idea, right? You can use slope for all of it, and you can prove all this stuff even if you're just given coordinates. All right, so we had a lot going on in that one, but that wrapped up everything to do with Chapter 5 and our quadrilateral.